Cyber Physical System Laboratory 2019 Annual Demonstration Development of 25-bit optical rotary sensors for direct driver motors. Design and optimization of sensors. A novel photosensors for a direct driver motor have been designed by NCTU CPSL. Sensors were manufactured, packaged, and implemented with practical motors and reached to the high performance based on taking the process optimization, the thinner package, and the no noise readout circuit under considerations. The first one of 6 major breakthroughs, process optimization. To reduce the leakage current, we performed several cross-comparison experiments on the sensor's surface metals. Select an appropriate process for the motor application. You can refer to the paper published by NCTU in IEDMS 2018 for more detailed information. The second one of 6 major breakthroughs, package of thin glass. By reducing the thickness of the package glass, the light source is closer to the sensor and approach the ideal collimate uniform illumination. After reducing the glass thickness, the sensor was added into the 28-pin package. Experimental results show the lumen square error reduced from 0.039 to 0.018, more than 50%. The third one of 6 major breakthroughs, low noise readout. During the experiment, the signal-to-noise ratio could be improved when different sensor cathode were powered by separated power sources. Adding bypass capacitors near the cathode is a simpler solution. With the addition of the bypass capacitors, the output signal's lumen square error was reduced. After measuring the spectral response of sensors, process 415 was chosen. The impedance was found at the target bandwidth of 200 kHz. Then, the bandwidth tests are investigated under different temperature conditions. The facility measuring the electrical parameters of the sensor are built in CPSL. The fourth one of 6 major breakthroughs, spectral response of sensors. Testing the response of the corresponding band spectrum of the 3 processes. Spectrum response unit is amperes per watt, which is independent of area. Therefore, it must be ensured that all the illumination sources are eliminated on the sensing material. The above picture shows the green spot near the 550 nanometer band focuses on a sensor. The absolute amperes per watt value were obtained by comparing the 3 processes with the standard sensor. Then, the process 415 is optimal when the 850 nanometer band of the light source is chosen. The fifth one of 6 major breakthroughs, bandwidth at different temperatures. After determining the use of process 415, different impedances were configured, and the sine waves from low to high frequency were emitted to the sensor, while the amplitude change of the sensor by 850 nanometer light source were recorded. Through the configuration and analysis of the amplitude changes, the matching impedance of 7 kΩ is confirmed to meet the 200 kHz target bandwidth. Then, we set the 7 kΩ as a fixed impedance value and the test bandwidth with an ambient temperature controller from -40 to 130 degrees Celsius. It is confirmed by the results that the self-made sensor can reach the target 200 kHz at -40 to 130 degrees Celsius and conform to the car specification AEC Q100. We will collaborate with the manufacturer to strengthen the controllable temperature range to reach the military grade. The following is the procedure to measure different bandwidths at different temperatures from the state monitoring and the temperature control. The current temperature is trying to stabilize at 40 Celsius. After the temperature is stable, adjust the offset of the output yellow signal and the reference red signal so that they are legend. Next, set the output signal to the AC vibration measurement mode. The variable frequency sine wave changes from low frequency to high frequency and measures the corresponding amplitude of the output yellow signal. Then change the temperature to 50 degrees Celsius and repeat the above measurement steps. Repeat the above steps. The amplitude value corresponding to each temperature can be obtained, and use this data to estimate the bandwidth of the process 415 at different temperatures. The last one of 6 major breakthroughs, process model. We established a measurement method after discussion with the process manufacturer, and measure the parameters of the sensor using the LCR meter and the source meter. There are some non-ideal electrical properties of the sensor. First, the current of the sensor. Second, the time delay caused by the pulse, the diffusion current, and the interface capacitance is aggregated into a non-ideal total capacitance. Third, it should be an ideal open circuit, but in reality, there is a shunt resistance. Fourth, it should be an ideal short circuit, but in reality, there is a series resistance.